Okay, we're back. This is a continuation of problem 2, homework 2. This is part C. Here we need to determine the probability of x1 being a 0 given that x3 is a 1. So this is kind of a reversal process because we want to ensure that this 1 is not due to a false condition, certainly not due to a 0 at the input causing a 1 at the output. That would be bad. So in order to do that, we have this expression here, but we want to determine if there's a 0 at the input given that there's a 1 at the output. The best thing to do is to break it into two sections. First, determine if there's a 0 at the input to the second channel, while there's a 1 at the output of the first channel. So essentially what we're going to end up doing there is we're going to say that this is going to lead to probability of x2 equals 0 given x3 equals 1, right? And this is equal to probability of x2 equals 0, x3 equals 0 over x3 equals 0 probability, and that is going to equal the probability of x3 equals 0 given x2 equals 0 times the probability of x2 equals 0 over probability of x3 equals 0. All this information we have, and that's going to work out to be 0.6 times 0.36 over 0.408. We can almost see that by inspection as well, because we have the 0.6 from the channel, the 0.36 here at the input to the second channel, divided by the output probability for a 0. And that gives us the desired result of, in this case, is 0.53. 0.53. And that's the halfway point. We have to do the same procedure, reflect it back to this input, the very input, and to do that, we're going to call it something slightly different. Probability of x1 equals 0 given x2 is equal to 0, and this is going to be equal to probability of x1 equals 0 and x2 equals 0 all over x2 equals 0, and this will equal probability of x2 equals 0 given x1 equals 0 times the probability x1 equals 0 over probability of x2 equals 0. We have all this information given to us, so it's going to work out to be 0.6 times 0.2 over 0.36, and that equals 0.333. Okay, again, that can be done by inspection as well. Now, so we have two probabilities here reflected back from the input, one to the halfway point and one way back at the very input. So to get the total probability of x1 equals 0 given that x3 is a 1, we're going to multiply both together. So we're going to have 0.53 times 0.333, and that's going to equal 0.176. So the probability of having x1 equals 0 given that x3 is a 1 is 0.176. That's it.